In the standard version of industrial history, progress begins with invention. Before the roar of steam engines and the spread of railways, there were simpler tools. Then came innovation, then productivity, then modernity. In this telling, water-powered sawmills appear as an early but logical step in humanity's steady technical ascent. Flowing rivers replaced human muscle. Rotating shafts converted nature into motion. Timber that once required teams of men with handsaws could now be processed with mechanical regularity. Output increased. Costs fell. Settlements expanded. The narrative is clean, linear, almost inevitable. Textbooks often frame pre-steam industry as a prelude, a preparation stage before the real transformation associated with figures like James Watt and the steam engine. Water power is presented as a bridge technology. Transitional. Important, but temporary. Museums display scale models of wooden gears and vertical saw frames. Labels emphasize ingenuity. Diagrams show how rotational force was redirected and amplified. The focus rests on mechanics, the efficiency of overshot wheels, the refinement of crank systems, the gradual replacement of reciprocating saws with more continuous cutting mechanisms. The broader message remains consistent. Machines extend human capability. Mechanization reduces effort. Industrialization marks advancement. In this version of history, water-powered sawmills represent a rational response to resource abundance. Forests were vast. Rivers were free. Timber was needed for ships, homes, fortifications, trade goods. Mechanized cutting appears not only efficient but necessary. A natural alignment between environment and human demand. There is little sense of conflict in this framing. The sawmill becomes a symbol of coordination between nature and technology. Flowing water drives wooden blades. Raw timber becomes standardized planks. Labor becomes organized. Production becomes predictable. Even when hardship is acknowledged, it is usually described as transitional. Early industrial labor was difficult, we are told. But over time, productivity would lead to prosperity. Mechanization would eventually improve living standards. The hardships of early industry are framed as temporary costs within a larger arc of improvement. The formula is simple. Technology increases output. Increased output strengthens economies. Stronger economies improve societies. Within that formula, water-powered sawmills occupy a modest but respected position. They demonstrate that before steam, before coal, before combustion, human societies had already begun converting natural forces into systematic production. Yet this familiar story rests on a quiet assumption that the introduction of machines primarily changed efficiency, that the central shift was technical. But what if the sawmill altered something else first? What if the transformation it introduced was not only about timber, but about control, over labor, over landscapes, over time itself? The mechanical description is precise. The economic narrative is smooth. But when we look closer at the environments in which water-powered sawmills operated, the alignment between productivity and well-being begins to look less seamless. One of the first tensions appears in the relationship between output and labor conditions. Hand-sawing timber was physically exhausting. Two men stood on opposite ends of a long pit saw, moving in rhythm, converting trunks into boards through coordinated effort. The introduction of water-driven saw frames reduced the need for that synchronized physical strain. This is often described as liberation from drudgery. Yet surviving labor records from early modern Scandinavia and German principalities suggest something more complicated. Workers were not necessarily freed from effort. They were reorganized around the machine. Instead of pacing their work according to physical endurance, They now adjusted to the rhythm of the wheel. The water flow dictated tempo. If the river ran strong, the saw moved continuously. If timber jammed, men had to intervene quickly. The hazard shifted from muscular fatigue to mechanical injury. Productivity rose, but so did the intensity of oversight. Mill sites became points of coordination. Timber had to be transported, sorted, fed into frames, stacked after cutting, and shipped onward. This required scheduling, storage management, and supervision. In many regions, sawmills were owned not by individual craftsmen, but by landholders, crown authorities, or merchant syndicates. The shift was subtle. The machine did not only replace motion, it centralized it. In Norway and parts of Sweden, water-powered sawmills expanded significantly during the 16th and 17th centuries under export pressures tied to shipbuilding and urban growth in Western Europe. Timber output increased dramatically, but forests near river systems were often depleted first. Remote areas remained untouched not because of conservation, but because transportation infrastructure did not yet support deeper extraction. Here a second mismatch appears. Mechanization is usually framed as efficiency. Yet the efficiency of the sawmill depended on proximity to flowing water and transport routes. Forests were reorganized according to hydraulic geography. Settlements shifted toward riverbanks. Seasonal labor patterns adjusted to thaw cycles and flood stages. The river determined more than power supply. It shaped labor timing, ownership disputes, and regional trade patterns. There are also fragments of documentation that complicate the narrative of smooth improvement. Complaints from small landowners appear in court archives. In some cases, independent sawyers protested the granting of exclusive milling rights to larger operators. Watercourses were regulated. Access became restricted. What had once been open woodland for local use gradually turned into regulated production zones. The machine did not simply increase timber processing speed. It redefined who had the authority to process timber at scale. In parts of Central Europe, authorities imposed limits on private sawmills, fearing overcutting or loss of tax revenue. In other regions, monopolies were granted to secure export contracts. The political management of mills suggests that they were never purely technical devices. They were economic instruments embedded in governance. Even the physical structure of the sawmill complicates the neutral image. The vertical reciprocating saw, driven by a camshaft attached to a water wheel, required steady pressure. Logs were fed forward incrementally, sometimes by ratchet mechanisms. If alignment failed, blades snapped. Injuries were common enough to appear in scattered medical notes, and yet these details rarely enter the main narrative. Instead, the story emphasizes the ingenuity of converting rotational force into linear cutting motion, the elegance of the crank, the refinement of gearing ratios. Technical manuals describe incremental improvements in blade durability and feed mechanisms. What they do not often explore is how the machine altered bargaining power. When cutting was manual, skill mattered. Teams developed coordination. Knowledge was embodied. With mechanized frames, expertise shifted toward maintenance and supervision. The labor force could be more easily replaced. Productivity increased, but so did dependency. On river flow, on capital investment, on centralized ownership. Another gap lies in the environmental consequences. Large-scale sawmills encouraged uniform cutting of straight, mature trees suitable for standardized planks. This shaped forest composition over time. Selective logging based on mechanical compatibility may have altered ecosystems long before steam-powered industrial logging accelerated the process. Yet ecological change rarely appears in early industrial narratives. Forest depletion is mentioned, but often as background context rather than as a structural consequence of mechanized extraction. There is also the question of pace. Water-powered sawmills expanded unevenly across Europe. In some regions, they proliferated rapidly. In others, they remained limited. Adoption depended on political permission, capital availability, and export demand. Not solely on technical feasibility. If the machine were simply superior, why was it spread so irregular? These small inconsistencies do not overturn the standard account. Water-powered sawmills did increase output. They did support trade. They did lay groundwork for later industrial forms. But the assumption that mechanization equaled straightforward improvement begins to look incomplete. Output rose. Control centralized. Forests reorganized. Labor shifted from coordinated autonomy to supervised rhythm. The machine did not merely slice timber. It rearranged relationships between workers and owners, between rivers and settlements, between forests and markets. And yet, most accounts still frame it as a prelude, a step toward steam, a mechanical curiosity before engines. If so much shifted before engines arrived, what exactly are we overlooking when we treat this phase as merely transitional? When industrial history turns toward interpretation rather than description, certain patterns begin to repeat. Water-powered sawmills are often positioned as early agents of human liberation. The logic is familiar. Mechanization reduces physical strain. Reduced strain allows specialization. Specialization accelerates economic growth. Growth improves living standards. This framework appears in survey textbooks, popular documentaries, and even in introductory economic histories. Machines displace effort. Labor migrates toward higher value tasks. Society advances. Yet when one compares this framing with contemporary records from the periods in which water-powered sawmills expanded, the alignment is less clear. Take the claim of liberation from manual sawing. Two men in a saw pit faced grueling conditions. The work was slow, exhausting, and physically taxing. A water-driven saw frame could process more timber in less time. This is true. But records from the 16th and 17th century Norway show that while the number of manual sawyers decreased in certain districts, overall labor demand around mills often increased. Workers were required for log transport, sorting, maintenance, supervision, river management, and export preparation. The machine did not eliminate labor. It reorganized it into more segmented roles. In merchant correspondence from Baltic trading cities, timber is discussed less as the output of human effort and more as standardized cargo measured in units. The language shifts from craft to volume. Efficiency becomes an accounting category. The social consequences of this shift are rarely foregrounded. Popular narratives tend to compress the timeline. They suggest that mechanization quickly transformed economies. In reality, the expansion of water-powered sawmills was gradual and regionally uneven. In Sweden, for example, export-driven sawmill growth accelerated under Crown regulation during the 17th century. But many rural areas continued using manual techniques well into later centuries. The coexistence of old and new methods challenges the image of rapid transformation. Another common distortion involves the portrayal of mechanization as inherently progressive in its impact on workers. The phrase "freeing men from drudgery" appears frequently in retrospective commentary. However, court cases and local disputes reveal tensions between small-scale operators and licensed mill owners. In several regions, independent sawyers protested restrictions placed on private cutting to protect centralized mills. Here, the machine appears less as a neutral improvement and more as a tool that favored capital concentration. Contemporary complaints sometimes describe exclusion rather than liberation. Access to watercourses was regulated, exclusive rights were granted, Forest use became tied to export quotas and taxation systems. Academic research into early industrial forestry complicates the simplified arc further. Environmental historians have shown that mechanized sawmills encouraged uniform cutting practices aligned with export specifications. Straight, mature conifers were prioritized. Forest diversity gradually shifted near river systems feeding mills. Yet popular history rarely connects early mechanization with ecological restructuring. Environmental change is often presented as a byproduct of later steam-driven industrialization, not as a process already underway under hydraulic power. There is also the issue of risk. Technical manuals celebrate improvements in gearing systems and feed mechanisms. But archival fragments mention broken blades, snapped shafts, and injuries caused by log misalignment. The mechanized saw did not eliminate danger. It relocated it. The risk shifted from repetitive strain to sudden mechanical failure. In popular retellings, these hazards are acknowledged briefly, if at all. They are folded into a general narrative of harsh early industry, which is then framed as temporary. The compression of time serves a narrative purpose. By presenting early mechanization as a stepping stone toward eventual prosperity, accounts minimize the duration of instability. Decades of uneven adaptation become a short transitional chapter before the steam age. The water-powered sawmill becomes a prototype, rather than a structural reconfiguration of labor and resource control in its own right. Comparing sources makes this simplification visible. Introductory histories often summarize water power as an efficiency breakthrough preceding steam. Merchant logs, by contrast, focus on price fluctuations, export quotas, and quality disputes. Local court archives record conflicts over mill placement and water diversion. Environmental studies track shifts in forest composition and river management. Each source emphasizes a different dimension. When combined, they resist a single linear storyline. The distortion is rarely overt. There is no explicit falsification. Instead, there is selection. Technical ingenuity is foregrounded. Social tension is backgrounded. Output is quantified. Labor autonomy is less measured. Environmental alteration is described as context rather than consequence. This pattern makes industrial history easier to teach. A sequence of innovations can be arranged chronologically. Students can trace improvements in efficiency. A clear narrative of progress emerges. Ambiguity is more difficult to integrate. If water-powered sawmills simultaneously increased productivity, centralized authority, altered forests, intensified labor supervision, and redefined property rights, the story becomes harder to condense into a single arc of improvement. The simplification serves clarity. It also serves continuity. By treating early mechanization as a rational step toward steam and steam as a rational step toward modern industry, the entire trajectory appears cohesive, yet the historical record suggests discontinuities. In some regions, mechanization deepened inequality between licensed operators and independent workers. In others, it bound local economies more tightly to volatile export markets. In still others, it introduced new administrative systems for resource regulation. These outcomes do not fit comfortably within a straightforward narrative of liberation through machinery. Another distortion concerns the speed of ecological impact. Modern environmental discourse often places large-scale forest degradation in the era of steam-powered logging and rail transport. But research indicates that concentrated hydraulic milling had already begun altering river-adjacent forests centuries earlier. The absence of dramatic imagery may contribute to this oversight. Water wheels turning quietly lack the visual force of smokestacks. Hydraulic power appears sustainable. It draws from flowing rivers rather than fossil fuels. The image suggests harmony. But harmony in energy source does not automatically translate into harmony in extraction scale. Even the language of renewable can obscure intensity. Rivers renew flow. Forests renew slowly. When cutting rates exceed regrowth, renewal becomes theoretical. Popular accounts rarely dwell on this imbalance in early mechanized forestry. Instead, they emphasize the cleverness of harnessing nature's motion. The result is a narrative that elevates technical creativity while compressing structural consequences. Water-powered sawmills were not misrepresented because they failed to increase output. They did increase output. They did expand trade networks. They did influence settlement patterns. The distortion lies in framing those effects as neutral steps within a larger benevolent progression. When we read merchant records, legal disputes, environmental analyses, and local accounts together, the machine appears less as a simple multiplier of effort and more as a pivot point in power relations. It reorganized who controlled timber. It standardized production for distant markets. It tied labor rhythms to hydraulic cycles. It embedded extraction within administrative oversight. These are not peripheral details. They are structural shifts. Yet in most summaries, they remain secondary to the mechanical innovation itself. The story becomes easier to tell when technology occupies the center and society adapts around it. It becomes more complex when technology is seen as emerging within negotiations over authority, profit, and land use. Water-powered sawmills do not overturn the narrative of industrial progress. They complicate it, and the complication suggests that what is often described as the natural unfolding of mechanical improvement may instead have been a selective reorganization of resources and relationships. One that fits certain interests more comfortably than others. If the simplification of industrial history serves clarity, it also serves stability. By the time modern states consolidated administrative authority in the 17th and 18th centuries, water-powered sawmills were not merely technical installations. They were measurable assets. They produced taxable goods. They supported naval construction, urban expansion, and export revenues. Timber was not an abstract commodity. It was strategic material. In several northern European kingdoms, timber exports became directly linked to state capacity. Shipbuilding required standardized planks. Fortifications required beams. Expanding merchant fleets required masts and hull components in predictable dimensions. Water-powered sawmills made standardization possible at scale. Standardization in turn made taxation calculable. The political value of mechanized milling was therefore not confined to efficiency. It was tied to legibility. Central authorities could more easily monitor output from licensed mills than from dispersed manual sawyers. Production sites became identifiable nodes within administrative systems. When rulers regulated sawmill construction along major rivers, they were not only managing forests, they were consolidating oversight. By requiring permits or granting exclusive milling rights, states reduced the number of independent actors participating in large-scale timber trade. This shift did not require conspiracy. It required incentives. A centralized mill simplified revenue collection. It also aligned production with broader strategic needs. During periods of naval expansion, for example, timber quotas could be adjusted through regulatory channels. The machine thus became a point of intersection between economic interest and political authority. In this context, the narrative of mechanical progress as civilizational advancement becomes useful. If mechanization signals order, productivity, and modernization, then promoting machines aligns with promoting state strength. The symbolic dimension should not be underestimated. Industrial imagery has long functioned as shorthand for advancement. Even before steam engines dominated skylines, water wheels turning steadily along rivers embodied controlled energy. They suggested mastery over nature's flow. Paintings and early engravings often depicted mills as signs of industrious settlement. Attaching technology to civilization provides a coherent identity. A society that harnesses water is framed as rational and forward-looking. The sawmill, in this sense, becomes not only a production site, but a marker of developmental status. This symbolic association benefits governing institutions. When technological expansion is equated with national improvement, resistance to regulation can be framed as resistance to progress itself. Again, there is no need for dramatic intent. The alignment is structural. Industrial development promises employment, export revenue, and military capacity. States promote it because it enhances fiscal stability and geopolitical leverage. In turn, narratives emphasizing technological advancement reinforce the legitimacy of those policies. The simplification of history plays a role here. A linear account, manual labor replaced by machinery, inefficiency replaced by productivity, supports the image of rational governance. Complexity, by contrast, complicates that image. If mechanization produced uneven benefits, ecological strain, and labor conflict, then the moral clarity of progress becomes less secure. Educational systems tend to favor cohesion. Industrial development is often taught as a sequence of breakthroughs. Water power, steam power, internal combustion, electricity. Each stage implies cumulative improvement. Such sequencing creates continuity between past and present institutions. Modern states that trace their administrative systems back to early industrial expansion can present themselves as inheritors of progress, rather than as products of contested reorganizations. There is also a geopolitical dimension. In the early modern period, access to timber influenced naval dominance. Northern European states with abundant forests and mechanized milling capacity held advantages in ship production. The ability to supply standardized planks efficiently supported maritime trade and military projection. Under these conditions, promoting sawmills aligned with strategic competition. When industrial history later frames mechanization as inevitable advancement, it smooths over the fact that these developments were embedded in rivalry and resource management. Water-powered sawmills did not spread simply because they were technically superior. They expanded where political permission, export demand, and capital investment converged. In regions where authorities restricted exports or prioritized local subsistence, expansion was slower. This unevenness reveals that industrialization was not purely technological diffusion. It was mediated by policy decisions. Narratives that center mechanical ingenuity often obscure this mediation. There is another advantage in presenting early mechanization as harmonious. Water power appears environmentally benign compared to coal. By highlighting hydraulic ingenuity, histories can portray pre-steam industry as balanced and adaptive. This framing reinforces a longer civilizational arc of responsible innovation. Yet, the regulatory records show concern about overcutting forests near major rivers. Authorities imposed seasonal limits and geographic restrictions in some districts. These measures suggest that extraction pressures were already visible. If this tension were emphasized in mainstream narratives, the image of seamless improvement would be harder to maintain. The political utility of simplified industrial history lies not in deception, but in coherence. A society that sees its technological past as progressive is more likely to view its present institutions as legitimate continuations of that progress. When machines symbolize order and rationality, they reinforce trust in systems built around them. Water-powered sawmills therefore occupy a subtle position. They represent early success in harnessing natural energy. They prefigure later industrial expansion. They fit comfortably into a narrative of gradual modernization. But that comfort depends on selective emphasis. If the focus remains on mechanical conversion of water into motion, the story remains technical. If the focus shifts toward regulation, labor restructuring, environmental management, and export strategy, the story becomes administrative and political. The difference matters because once the machine is understood as embedded within governance structures, it becomes harder to describe industrialization as a neutral unfolding of innovation. It appears instead as a negotiated process, shaped by fiscal needs, strategic priorities, and symbolic ambitions. Water-powered sawmills sliced timber. They also fit into emerging systems of oversight and competition, and the way we remember them, primarily as ingenious devices, may reflect the enduring convenience of keeping that broader context in the background. Outside the main arc of industrial storytelling, there are documents that rarely make it into general summaries. They are not dramatic. They are not ideological manifestos. They are administrative reports, local petitions, forestry surveys, maintenance logs, merchant letters, and early statistical compilations. Individually, they seem minor. Collectively, they complicate the picture. Labor inspection notes from parts of 17th century Scandinavia describe seasonal congestion around mills during peak export periods. Workers waited for river levels to stabilize. When floods damaged mill structures, repair crews were assembled quickly, sometimes drawing labor away from agricultural cycles. These disruptions appear as logistical details. They are rarely integrated into broader narratives of mechanization. Forestry ordinances from Central European territories include clauses regulating the diameter of trees permitted for cutting. The concern was not environmental preservation in the modern sense. It was supply management. Authorities feared depletion near navigable rivers because those forests fed taxable export streams. The implication is quiet, but significant. Mechanized milling did not merely increase output. It required regulatory frameworks to manage accelerated extraction. Merchant correspondence from Baltic ports frequently mentions quality disputes. Planks warped during drying. Boards cut too thin reduced structural reliability for ship hulls. Buyers demanded consistency. Sawmill operators adjusted cutting techniques accordingly. Standardization was not automatic. It was negotiated between producers and distant markets. Technical treatises from the period often focus on mechanical refinements, improvements in camshafts, feed mechanisms, blade tension. Yet in the margins of these manuals, one sometimes finds references to timber sourcing and water flow unpredictability. Machinery operated within ecological constraints. Rivers froze. Drought reduced capacity. Ice flows damaged wheels. Hydraulic power was renewable but not stable. In several regions, mill owners petitioned authorities for permission to divert streams or construct dams to increase reliability. These petitions occasionally triggered complaints from downstream communities concerned about irrigation or fishing access. The sawmill's presence altered water politics. This material rarely appears in condensed industrial histories. It does not fit easily into a story of ingenuity leading to growth. It reveals friction. There are also medical records, fragmentary but revealing. Injuries involving crushed hands or fractured limbs appear in parish registers and local hospital accounts. They are not statistically comprehensive, yet they indicate that mechanization carried new forms of risk. Unlike manual sawing injuries, which were often repetitive strain or fatigue-related, mechanical accidents could be sudden and severe. The shift in risk profile suggests that the machine changed not only productivity, but exposure. In some lesser-known academic studies of early industrial communities, researchers have examined wage patterns around hydraulic mills. Evidence suggests that while certain skilled maintenance roles commanded higher pay, general laborers did not always experience sustained wage growth proportional to increased output. The benefits of efficiency were unevenly distributed. Export records provide another layer. During peak demand cycles, often tied to naval conflicts. Timber exports surged. When demand collapsed, mills reduced operations. Workers experienced fluctuations in employment that were not always smoothed by local economies. Mechanization increased scale. It also increased vulnerability to distant markets. This connection between local forests and international politics is seldom highlighted in mainstream accounts of pre-steam industry. Yet naval expansion in Western Europe shaped timber demand across the Baltic and North Sea regions. Water-powered sawmills became embedded in geopolitical rhythms. There are also records of resistance. In some districts, communities dismantled unauthorized mills that diverted water excessively. In others, disputes arose over rights to build additional milling capacity. These conflicts suggest that mechanization was not universally welcomed as progress. It was contested, negotiated, sometimes restricted. Even within technical archives, the social dimension surfaces indirectly. Instructions on maintaining blade sharpness sometimes mention the need for disciplined workers to monitor feed rates. Mechanical precision required human vigilance. The machine did not eliminate skill, it redistributed it. Environmental surveys conducted centuries later, using dendrochronology and archival reconstruction, indicate that certain river-adjacent forests experienced long-term compositional shifts traceable to early mechanized logging patterns. Selective cutting for straight trunks influenced age distribution and species dominance. These findings rarely appear in popular narratives of early industry. They complicate the image of water power as gentle extraction. None of these materials overturn the basic fact that water-powered sawmills increased timber output and facilitated trade. But they reveal layers that are often omitted. They show administrative adaptation to accelerated cutting. They show wage stratification within reorganized labor systems. They show ecological feedback emerging earlier than commonly assumed. They show communities negotiating access to water and forest resources. Most importantly, they show that mechanization did not unfold in isolation. It was embedded in networks of policy, trade, ecology, and conflict. The reason these sources remain peripheral may be structural. They do not lend themselves to clean diagrams or concise summaries. They require cross-disciplinary reading, legal history, environmental science, economic analysis. Industrial storytelling often prioritizes the visible machine. Water wheels are tangible. Blades are concrete. Administrative clauses and wage tables are less cinematic. Yet without them, the picture remains partial. When these less circulated materials are considered together, the water-powered sawmill appears not as a quiet prelude to steam, but as an early site where technological capacity, state oversight, market volatility, and environmental constraint intersected. The machine sliced timber. The surrounding system shaped lives, and much of that shaping remains outside the simplified narrative that frames mechanization primarily as technical ascent. What remains, after examining the technical diagrams, the export ledgers, the forestry ordinances, and the scattered injury reports, is not a countermyth. Water-powered sawmills did increase output. They did enable larger trade networks. They did support shipbuilding, urban growth, and administrative consolidation. None of that disappears. What becomes less stable is the assumption that these outcomes were primarily technical in origin, or that their social effects can be summarized as early steps toward inevitable prosperity. The familiar narrative rests on several quiet premises: that mechanization naturally improves labor conditions, that productivity gains distribute benefits broadly over time, that renewable energy sources imply balanced extraction, that technological refinement leads societies forward in a largely linear sequence. Each of these premises contains partial truth. None is universally reliable. In the case of water-powered sawmills, productivity did rise, but labor autonomy often narrowed. Forest management became more regulated. Yet extraction intensified near transport routes. Administrative systems grew more sophisticated, but they also centralized authority. The machine did not simply extend human capability. It reorganized human relationships between workers and owners, between communities and rivers, between local forests and distant markets. The simplification of this process into a neutral progression may be understandable. Linear stories are easier to teach. They create continuity between past and present. They align technical ingenuity with social improvement. But the archival fragments suggest a more conditional reality. Mechanization required permission. It required capital. It required regulatory frameworks. It required markets prepared to absorb standardized goods. Where those conditions aligned, mills expanded. Where they did not, adoption stalled. The machine did not drive history independently. It moved within boundaries shaped by policy, geography, and demand. This does not diminish technological creativity. It reframes it. Water wheels and reciprocating saw frames were ingenious. Their designers solved real mechanical problems. But ingenuity alone does not explain why certain mills were licensed and others prohibited. Why forests were prioritized for export rather than subsistence. Or why wage gains did not consistently track output growth. Those outcomes reflect decisions, negotiations, and constraints. Even the image of hydraulic harmony, flowing water powering orderly production, deserves reconsideration. Rivers fluctuate. Forests regenerate slowly. Markets shift abruptly. Stability required continuous management. The sawmill appears steady in museum models. In practice, it operated within instability. If the early phase of mechanized timber production already displayed uneven labor impacts, ecological pressure, and administrative consolidation, then the later steam age did not introduce these dynamics from nothing. It amplified patterns already present. This realization does not provide a replacement narrative. It leaves open questions. How should we measure improvement when gains in efficiency coincide with new forms of dependency? At what point does renewable energy cease to imply sustainable use? How do we distinguish between technological possibility and political choice? The story of water-powered sawmills resists reduction to triumph or failure. It reveals entanglement. Machines are not neutral engines guiding society along a predetermined path, nor are they external forces imposed upon passive communities. They emerge within negotiations over land, labor, and authority. The standard narrative of industrial progress remains influential because it offers coherence. But coherence can conceal contingency. Before engines burned coal, rivers already turned wheels. Before smokestacks reshaped skylines, forests were reorganized for export. Before industrial labor became synonymous with factories, hydraulic mills had begun aligning work rhythms with mechanical cycles. If so much transformation occurred quietly, under the sound of water rather than steam, what else in our industrial memory has been simplified into inevitability?